Okay, we're starting section 13.2. Well, we're actually in the middle of section 13.2. And we left off last time with, we talked about maybe converting radians into degrees and degrees to radians. First of all, we got to know what a radian is, first of all, before we can convert from one to the other. Right? It'd be nice to know. So here we have a circle. We have, from here, from the center of the circle to this point right here would be a radius, as it's labeled. And it forms an angle, okay? I could have all these, I could have a whole bunch of lines, radii coming out from there. And this forms an angle, we'll call it theta. Now here's what a radian is, okay? It's not that hard to understand. If I was able to take this radius, pick it up, and wrap it around the circle, okay? Pretend it was like a string, okay? And if I was wrap it around the circle, the distance, okay, that it covers, or actually, it's not really the distance, the angle that's formed, okay, by that distance around from here to here would be 1 radian. So the angle is a radian. So really, there's two ways to talk about angles. One is by degrees, which you're used to, right? That's just common. But the second way is by radians. In here, we're going to do both of them, okay? We'll talk about degrees and radians. When you start moving up higher levels in math, pre-calc and calculus, in fact, I talked to like Stephen and Matt and those guys, and they said they use almost primarily radians in calculus. They hardly ever use degrees, okay? So it's nice to know, because when you go higher up, you're going to use radians quite a bit, all right? Joel, do you have a question?
I didn't quite hear what you said.
All right, let's do this. I'll show you now. This is kind of hard to draw, but let's go a different color. If I was going to take this radius from here to here, right, and stretch it around here, pretend it was a piece of string, all right, and I was able to form it to that outside of the circle, this distance from here to here is the same thing as that distance right there. So if I took that radius, and it's not that easy. Oops. Well, it's not going to look very pretty, but you get the idea. That's close enough. All right, if I took that radius right there, wrapped it around, this distance right here of that curved part, and this distance is exactly the same. Well, the angle that's formed is 1 radian. All right, so right there, we'll just put it up here. That would be 1 radian, RAD for short. You with me on that? Now, if I had a smaller circle, let's say I had a little tiny circle, and I took the radius of that little circle, it would form the exact same angle, okay? And I wrapped it around the circle, it would form the same angle. Remember, it's a measure of degrees, okay? It doesn't matter how big or how small the circle is. It's not the length from here to here. What is it? It's the angle that's formed. Everybody got that? That's 1 radian. Well, let's count up how many radians we have. If that point right there would be 1 radian, and I took that radius and I stretched it again around the edge of this circle, then what would it be right here? What would your angle be right here?
2.
It'd be 2 radians, okay? You follow me? So that would be 1, that would be 2. Then from here to here would be how many altogether from the beginning? That would be 3 radians. Okay, now look at this. Look at this tiny little bit right here. Well, let's think about it. It's circles. We're dealing with circles, and we're dealing with 1, 2, 3, and a little tiny bit. It's pi, exactly right. Okay, this little bit right here is 0.14159, blah, 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 of the radius. Okay, so if I knew what the length of the radius was, then this is 0.14 of the radius. You follow me? So this is 1 radian, this is 2 radians, this is 3 radians, and then from here to here it's just a little bit more. So what's a little bit more than 3? Pi. 3.14 is a little bit more than 3, isn't it? Okay, so 3.14 is pi. So from the beginning, right here, all the way around to here, that angle, what would that be? Oops, forgot to take that off of there. Let's try that again. If I went from here all the way to here, oh, it did it again. Boom, boom.
What would be 180?
There we go. Yeah, it'd be 180 degrees, and what would that be in radians? Let's try this one more time.
How do you abbreviate radians?
Yeah, I wanted to. There we go. That's better. You don't, just RAD. You just put radians. RAD for radians. All right, so from there to there would be pi radians. So watch, I'm going to put pi, and that's in radians. In fact, after a while, we're not even going to put radians at all. We're not even going to put RAD. We're just going to put pi right there. Okay? So right here would be 0 pi, because we haven't even gone around the circle yet, have we? So all the way to here would be 1 pi. What if we went all the way around the circle? Now, how many degrees is all the way around a circle? Okay, what would it be in radians then? It'd be 2 pi. Very good. All right, because this is 1 pi, this is another pi, so that's 2 pi. Follow me? All right. What about, let's do something a little trickier here. What if we drew a perpendicular? So that's 90 degrees right there. So that's 90 degrees. How many radians?
Ben Holly, please come to the office.
So how many degrees would it be right here? That's 90. Okay, what about radians?
Pi over 2.
Pi over 2. Yeah, you could say half pi, you could say 0.5 pi, but we say, to be consistent, so everybody says it the same way, we're going to say this is pi over 2 radians. You okay with that? Because it's half a pi. Because from here to here is 1 pi. Now, when you think of a pie, like a PIE, you're eating pumpkin pie or apple pie, you think of the whole thing. But that's not what don't think of that. Okay, a whole pie is actually 2 pi radians. Okay, you follow me? Like a whole pizza pie, okay, is 2 pi radians. All right. So it's unfortunate that, this is only half of a pizza pie. All right. But anyway, let's do this. What would it be if I went down to here? First of all, how many degrees is that down there?
1.5 pi.
How many degrees? Degrees. Right here. It's 270, right. So this would be 270 degrees, wouldn't it?
Yeah.
Okay. Oopsie daisy.
Like
I controlled Z too much. Counterclockwise. Yeah. Yeah, it's always counterclockwise. Right, that was previous lesson. All right. So this is 270 degrees. Now watch. This is half a pi. This is 1 full pi. Then this would be what?
3/2 pi.
Yeah, 1.5 pi, or that's how we say it. James got it. 3 pi over 2. That's how we're going to write it. You could say 1.5, you could say 1.5 pi, but the way that we normally write it, that you'll see in most places, is 3 pi over 2. It's 3 halves, 1.5 pi. Make sense? Because that's half a pi, full pi, 1.5 pi, 2 pi. And you could keep going around, couldn't you? And keep adding more and more to it if you wanted to. We're just going to go one time around the circle. Everybody cool with that? Yes, sir.
Could you go clockwise and say like negative?
You could.
pi radians?
Absolutely. That's a good point. I didn't even bring this up in the other class. But you could go counterclockwise. Yeah, I got to think. Okay, 3 is here, 6 is here. So this is clockwise. And you're right. You could say that this is what? What would this be? Instead of positive, you could say it's negative pi over 2, couldn't you? If you went around to here, you could also say this was what? You could also say it's negative pi, couldn't you? Just depends on the direction. The positive says you go this way. The negative says you go this way.
So when you're dealing with radians, could you say, like actually write, that 3 halves pi equals negative pi over 2 radians?
Uh-huh.
That's
Yeah, negative 3 halves pi right here is just what we did. Negative 3 halves pi or negative 3 pi over 2 is the same thing as positive pi over 2. Exactly right. Okay? That's in radians. You follow me? The negative and the positive just tell you which direction you're going. Positive means you're going this way. You're going up and around, right? The negative says you're going this way, which would be what? Down and around. Okay, that way you can keep the negative and positive kind of similar to each other, all right? All right, let's stop this part of it, and we'll go on to, I got some other screen I'm going to show you after this next part.